Okay, solve exponential equations and inequations. So this is in 13D, back to the normal book. So, got some equations. Unsurprisingly, I'm going to want to solve those. Well, how do I deal with such things? So, first thing we want to notice is, well, if I knew what this was as a power of 2, I just have 2 to the something equals 2 to the something. So let's do that. 2 to the 7. Okay, great. Well, what does that mean? Well, hang on, they're both base 2. So that means the powers must be the same as each other. So therefore, this must be true, and now we're in very easy territory. So that makes life pretty easy. So the basic gist with all of these is get them down to talking about the same base. Okay, well, what are we doing with here? Okay, 27. 27 doesn't multiply up to 81, so those are really big numbers. So at this point, it becomes very useful to know a whole bunch of your powers. So I would recommend from powers of 2, 2 through to 10, powers of 3 from 2 up to 5, that's for 3s, 4s and 5s. I'd recommend knowing, so 3 to the power of 2, 2 to the power of 3 to the power of 4 to the power of 5, 4 to the 2, 3, 4, 5, 5 to the 2, 3, 4, 5, and then for 6 to 10, although 10's pretty obvious, so I won't even bother writing that. 6 to 9, you want to know squared and third. Arrow. Cool. So those will massively speed up your thinking, and I'm not going to give them to you because if you work them out, you're more likely to remember them. Okay, well, what have I got? 27 and 81. Hopefully, after you've done a little bit of thinking, these are both powers of 3. Okay, so this is 3 to the power of 3. All of that is to the power of 2x plus 2. And this is 3 to the 4. All of that to the power of, x, not 3. X minus 1. Okay, well, index laws, so 3 to the 3 times all of this, so there. 4 times all of this. There, great, we've got the same base, so we can ignore those now. This has to equal this. And now we're back in easy mode. What am I going to do? Minus that off. Minus this off. X negative 5. Done. Beautiful. Okay, well, slightly more complications now. Okay, now we've got fractions moving around. But hang on, fractions are just negative powers. Okay, so 25 and 125. They're both base 5, so squared to the 2x minus 1. And this is 5 to the 3 to this thing, but that whole thing's a negative power. So I'm going to make it negative x minus 4. Cool, okay. Well, how can we manipulate this any further? Well, I've got all the 5s there. I should simplify out these powers. So therefore, I've got 4x minus 2, negative 3x plus 12. Cool, move these across. 7x equals 14. X is 2. Beautiful. Now, we should have been doing this the whole time. Something we should have been doing is, this is not at all obvious that that's 2. So we should have been checking these as we went. So x is 4, 4 plus 3, 7, 2 to the 7 is 128. Yep, that's good. X is negative 5, okay. So we've got negative 5 makes negative 10, makes negative 8. So I've got negative 8 there, this negative 6, okay, this is 3 to the 3, this was 3 to the 4, 3's match, 3 times negative 8 is the same as 4 times negative 6, yep, both negative 24, so that checks out. This guy, 2, so we've got 5 to the 2, and then this guy becomes what, 3? This guy is 5 to the 3 to the negative minus 2, so that becomes positive 2, so I've got 5 to the 2 to the 3, 5 to the 3 to the positive 2, yeah, they're the same. Beautiful, next guy. Well, we've got a whole bunch of things, but 4, 8, 16, hopefully the number that comes to mind is 2, not 4, because this is not a power of 4. So, we're going to shift everything into base 2, so this is 2 to the 2 to the 2x plus 1. Now, I'll leave it there for now. 2 to the 3 to the 3x minus 4. 2 to the 4 to the 2x plus 5. Okay, great. Expand all these out. Everything is in base 2, but we should hold off on that for a second. Is 4x plus 2 multiply 2 to the 9x minus 12, 2 to the 8x plus 20. Now, what a lot of people do inadvertently is they get rid of those bases a bit early, and then they just start, oh, this multiplied by this, but that's no good, because if we're multiplying these, the powers add. So, I've got 2 to the add the powers, 13x minus 10, 2 to the 8x plus 20. Brilliant. Now I've got only two expressions, so now I can get rid of those bases. 13x minus 10, therefore 8x plus 20. Cool. And now we're just back in easy mode, so 5x equals 30, x equals 6. Yeah, not at all obvious that that's correct, so we should check it. Okay, so what have we got? In fact, I might write this down here. So we've got 2 to the 2, okay, 6 in there gives me 13, times 2 to the 3, 6 gives me 18 minus 4 is 14, equal 2 to the 4 to the, what am I doing, 12? Yep, 12 and 17. Brilliant, okay, well, that would mean that these powers add, so I've got 2 to the 13 is huge, add 3 to the 14 equals 2 to the whatever, equals 4 to the 17. Now, that's a big number, so we're going to need to check with technology. See if we can type all that in right. And then 4 to the 17. Nope, that's not the same. And it definitely shouldn't be the same because this is bigger. What have I done? Let's double check that. So, 4 is 2 to the 2, and then I've got 6 is 13, yes. 2 to the 3 is 8, this is 6, so 18 minus 4 is 14, yes. 4, yes, and we're putting in 6, so that's 12 and 17. So I've got 2, oh wait, is this 2 times? Oh, it's times, it's not to the power of, silly. Broke them up as extra powers when they should have been like that. Got carried away with powering. Okay, 2 to the 13, 26 is 30, 42, is 40, 68. Cool, 26 plus 42 is 68, yeah, that checks out. Beautiful. Good thing, I was a little bit worried there. Okay. We've got this go. Okay, well, this is looking really different because all these ones just had multiplies and divides. Now we've got pluses in there. Well, we're going to have to be a little bit more creative. As a general rule, whenever you see pluses in exponentials, there's almost certainly going to be a trick to it. In this case, what we want you to notice is, actually no, we'll rewrite first. This is the same as 2 to the x to the power of 2 plus 6 times 2 to the x plus an 8. Okay, great. So why did I do that? Well, now I've got this common term. So I'm going to let a equal 2 to the x. Okay, great. Well, why have I done that? Because, we'll keep writing in red. A squared plus 6a plus 8 equals 0. We've changed the kind of equation this is now. Now we're in an quadratic equation. We know how to solve those. Well, hopefully we do by now. A plus 2, a plus 4. I think, is that what I wanted? Yes, is negative. Hang on, I get the feeling I dropped a negative when I set this question up. Bother. This should have, oh, that should have been minus. I never changed it. Sorry about that. Fix. And fix, so this should have been -2, -4. There we go. Brilliant, okay. So we've got this, okay, well, therefore a must equal either 2 or 4. Okay, well that was a, but what we want is x. So 2 to the x must equal 2 or 4. 2 to the 1 would give me that, or 2 to the 2 would give me that guy. Okay, beautiful. The last thing you should always do, particularly whenever you've changed form, is check your answer. So, okay, if we have 1, that would be 2 to the 2 would be 4. Okay, what are we doing ones? So that's a 2, so that's minus 12 plus an 8. Does that check out to be 0? Yep, that checks out, so that one's good. Next one with 2. 2 to the 4 is 16, minus 6 times 4 would be 24, plus 8. Does that check out? Yep, that checks out. Great, so we've got 2 valid solutions. Fantastic. Okay, well, here's something that's similar. Notice we've got a minus in here, so we've got an extra thing that we haven't had before, so we're probably going to have to do some trick. We've got a lot of 5s going on, so that's a pretty big hint that we're probably going to need 5. Did I write that the wrong way? No, that's right. 5 to the x squared minus 24 times 5 to the x again equals, now, I could make this 5 squared and everything. I'm actually going to make it 25 because these are the pieces that I need. This is just a red herring. We can leave it as 5 to the 2 if you want, but very quickly you're going to have to get rid of it. There's my common piece, so I'm going to let a equal 5 to the x. Okay, so we've got, oh no, keep it ready because we've changed form. A squared minus 24 by a. Now, for a quadratic, I need this to be on the other side. Minus 25 equals 0. Notice that if I kept this as 5 squared, it'd look a bit weird. We wouldn't immediately recognise it as a quadratic. Cool. Solve quadratic. Minus 25 plus 1. Cool. A equals 25 or negative 1. Back into the blue world. So, what was it? 5 to the x either equals 25 or negative 1. Therefore, x is, well, that's 2. Now, or, hang on, 5 to the x equals negative 1. 5 to the power of something equals a negative? Well, that's not possible. So, no good. And the last thing we should do is just check that this worked. So, 5 to the 25, 25 to the 2 is 625. This is 600, and this is 25. That's a minus in between. Yep, that checks out. Beautiful. Last complication. What if we have inequalities? 9 times out of 10, whenever you have an inequality, switch it to an inequality, deal with the simpler version first, and then go back and see if it to see what the complication is. So, first thing, well, if I was treating this as an equals, what I'd actually care about was getting them in the same base. So, do that, because that definitely hasn't changed anything. Okay, great. Well, I just need when this is bigger than this. That's fine. So, x just has to be bigger than 4 on 3. That's nice and easy. Now, something that you should generally check, okay, so if x was 1, that would fail this, and if x was 2, that would pass. So we should check those. X to the 1 becomes all over 8. 8 is greater than 16. No. Well, that's good because we said that should fail. X is greater than 2. X is 2. Should pass. So 3 by 2 is 6. 2 to the 6, 64. 64 is greater than 16. Yeah, that passes. So that gives us confidence that we've got the right result. Or that our inequality is the right way around. Beautiful. Next guy. Similar story, we need them in the same base before we do anything else. Well, that's 5 to the 0, so I need this to be less than 0. Okay, fine. Now, there's a bunch of different things that you could do to stuff this up, so let's do one of those, minus the 3. Now, divide by negative 2. Well, because you're dividing by a negative, you've got to flip that around. So, x is greater than 3 halves. Okay, well, we need some conditions to check. How about x is 1, should fail, and x is 2, should pass. Okay. Alright, let's go. Fine, 1. So, negative 2 times 1 plus 3 would be 1. 5 is, to the power of 1 is 5. Less than 1? No. But we were expecting it to fail, so that's good. X is 2. Negative 2 by 2, negative 4 is negative 1. 5 to the negative 1 is 1/5. 1/5 is less than 1. Yep, that checks out. So that's basically it for exponential equations and inequations. For the most part, the general rule is get it all down to the same base first, Memorizing those values will help you a lot, because as soon as you see them, you'll recognize them and you'll know what kind of problem you're dealing with. The other thing is, if you've ever got inequalities, deal with them as equals first and then worry about the flip-flops. And if you've ever got pluses or minuses in between terms in an exponential, it's probably going to turn into some sort of quadratic. Cool. So that's 13D. Email if you've got any troubles. Otherwise, cheerio.